welcome to Half-Lives. To give you a visual to start with our Half-Life notes today, I'm going to start with a visual that you don't actually have in your note packet, but it does follow along with the example talking about the number of carbons. I did not use real numbers of molecules that you would have, but kind of simplified this down into nice full numbers. Looking at this diagram right here, initially, if we imagine that we had a sample of carbon-14 and we had 32 atoms, which really isn't very many, but after we went through a half-life, we would only have half of that remaining, so we'd have 16. After another half-life, we'd be down to 8. After another half-life, we'd be down to only 4. After another half-life right here, we'd be down to 2. And then finally, after another half-life, we would be down to 1. I like this visual because it gives you a nice visual of that exponential decay where we have this downward slope, but as you can see, we continue to go lower and lower without ever actually reaching 0. So look at this, we initially had 32 carbons. After one half-life, we went down to 16 carbons, or 50% of the original. Another way you can write this is a fraction, 1/2. After a second half-life, we've gone down to 8, which is 25% of the carbons, or 1/4 of the original carbons. After a third half-life, we're down to 4 remaining carbons, 12.5%, or 1/8 of our original numbers of carbons. As we go down again to 4 half-lives, we went down to 2 remaining, which is 6.25%, 1/16 of our original carbons. After 5 half-lives, 1 carbon remains, and this is 3.125% of the original carbons, or 1/32. What's important to keep in mind is if we went to a 6th half-life, we're not really going to 0 here. So we would actually go to 0.5 carbons. So do you really have half a carbon? Not exactly. But remember, these would be based on numbers like Avogadro's number, 6.02 times 10 to the 23rd particles. These numbers are so large that it's nearly impossible to really ever get to the point where you have fractions of atoms left. And no, it is not possible to reach 0. As you learned about exponential decay in math, you have this nice curve going down, but it does not ever actually reach 0. Typical half-life problem you might have to solve, we are going to need reference table N to look up our values for our half-lives. Radon-222 is a carcinogenic house pollutant. If your basement was found to contain 20 grams of radon-222, how much would remain after about 19 days? So important information here is the fact that we are talking about radon-222. We are, after a certain amount of time, at the beginning of a certain amount of time, we have 20 grams of it, and we want to find out how much should be left after a given amount of time. So we're going to go to table N and find radon-222. Its half-life is 3.823 days. We're going to determine how many half-lives overall will occur. So we want to see how many times we can go through that period of time within 19 days. So we're going to take our total time, and we're going to divide it by the length of the half-life. In this case, that's 19 days divided by 3.825 days. Now, this does give you a decimal, 4.96. We can round this up. It's pretty close to 5 half-lives. We'll be using all whole numbers of half-lives. There is ways to do these problems if you have a decimal half-life, but ours are going to come out so they're pretty much equal to a whole number of half-lives. I like to draw something called an arrow diagram. So I'm starting with 20 grams, and then I chop this in half by my first half-life, go down to 10 grams. My second half-life is going to take me to 5 grams. My third half-life is going to take me to 2.5 grams. Gotta go down, I'm running out of room. My fourth half-life, 1.25 grams. And finally, when I go through my fifth half-life, which is how many I want to go through, I'm going to end up at 0.75 grams of radon-222. How long will it take for 400 grams of P32 to decay to 50 grams? So first thing we're going to do is find P32. That is 14.28 days. half-life. In this question, they're not giving me a total amount of time. So what I actually want to do, I have two amounts. So I'm going to figure out how many half-lives that was. So if I start with 400 grams, if I cut that in half once, it'll go to 200 grams. If I cut that in half a second time, it'll go to 100 grams. And if I cut that in half a third time, that's going to take me down to my 50 grams, which is what I want according to the problem. So I went through 3 half-lives here. I'm going to multiply each of those 3 half-lives times my 14.28 days. And this is going to give me a total of 42.84 days. Actually, just realized I had cut a problem out of your notes that is on this slide. I am going to walk through it just so that you have an opportunity to see a question that involves percent. These are pretty straightforward, not a whole lot different, except for we do have percents instead of grams. So I want to know the percent of potassium-42 in a sample that will remain after 49.6 hours. So potassium-42 has a half-life 12.36 hours. My total time is 49.6 hours. So I'm going to divide this to determine my number of half-lives. This comes out very close to 4 half-lives. So next I want to determine what my percentage will be that remains. Keep in mind when we're talking about percent, we're always starting with 100%. And I need to chop this 4 times. My first chop gets me down to 50%. My second chop gets me to 25%. My third chop gets me to 12.5%. And my fourth chop will take me to my answer, which is 6.25%. So very often these questions can be asked using fractions or percents. And in this case, you just start with 100%, or a whole number 1 would be how you do this for a fraction, and you chop it in half each time. You promise to try on your own, so I'll show the answer in just a minute. Go ahead and pause this and try these few problems. The answer for our first problem is 2.5 grams. Just to show you work for this quickly, we have a total of 24 days divided by 8.021 days, giving us about 3 half-lives. We're then going to take our initial 20 grams, chop it 1 time to 10 grams, chop it 2 times to 5 grams, and my third chop is what takes me down to my 2.5 grams. So remember, each one of these chops is representing approximately 8 days. My first 8 days, my second 8 days, and then my third 8 days give me that total 24 days. If a 100-gram sample of carbon-14 has decayed to 25 grams, how much has passed? 11,400 and, sorry, that should actually be 30 years. I have to edit that. So let me walk you through this really quickly. We have an initial starting 100-gram sample. That gets chopped to 50 and then to 25 by going through 2 half-lives. Each half-life for carbon is 5,715 years. 2 times that is going to give me 11,430 years. Sorry for the original error in that. Finally, question number 3. If 35 grams of a sample of cobalt-60 remains after 15.78 years, what was the mass of the original sample? The answer to that is 280 grams. So we have to do to solve this problem. We do know our total years that are going by. So this is 15.78 years total divided by our half-life, which is 5.271 years. We're talking about approximately 3 half-lives here. Our 35-gram sample is chopped 1 time, or I'm sorry, I'm going backwards here. My 35 gram sample is what I have that's remaining after this time. So instead of chopping, I'm going to backtrack 3 half-lives. So I'm actually doubling here. So before that last half-life, before one of the half-lives, I had 70 grams. Before another half-life, I had 140 grams. And then before another half-life, for a total of 3, I had my full 280 grams.